So, dear colleagues, we are ready to start this second half part of the day concerning UAP's observables. This session is dedicated to the radar and electromagnetic observables after the session of this morning dedicated to the optical observables. We have the pleasure to welcome as participant Brigadier General retired for the French Air Force, French Air and Space Force, Jean-Marc André, who is part of the Sigma 2 Commission, and is going to talk about the Jersey case analysis using visual and radar data analysis. We have also Dr. Joshua Pierson, belonging to SCU, with a background in the domain of strategic and security, and his presentation will be about detectable signature of UAP, building on intelligence, picture, and capabilities through structured analytic techniques, PhD dissertation by Joshua Pierson, and also Dr. Sarah Little and Robert Powell were well known. They have already participated to the webinar one last year. They are from SCU, and they will provide a presentation on the Stephenville UAP case analysis. So the floor is yours. We start with the presentation from Jean-Marc André, and we will come back later with possible questions and so on.
The Jersey case is an interesting model of data crossing. Indeed, it has been possible in real time to compare the visual observation of an UAP by pilots in flight with the radar detection situation as perceived by the air traffic controller. Unfortunately, this did not solve the mystery. It wasn't possible to characterize the phenomenon, and no plausible explanation could be identified. Today, we resume the study of this case by starting from the radar data which have been recorded. It's a very interesting analysis, but full of surprises that still leave a lot of questions unanswered. It demonstrates what is possible to do in UAP investigation and what is not possible to do. Let's recall the story of the event. On the 23rd of April 2024, this three-cylinder, a three-engine piston-powered utility aircraft, is cruising southward over the sea inbound to the Channel Island. It's 3:00 p.m. British Summer Time. The three-cylinder comes from Southampton with 9 passengers. The pilot, Ray Boyer, maintained his aircraft steady at 4,000 feet and prepared to descend for landing at Alderney, the northernmost island. At one point, Ray Boyer notices a bright light straight ahead in the axis of the aircraft. Weather conditions are fair, the sky is cloudy, but horizontal visibility is good. There is a layer of haze at 2,000 feet below the aircraft. The view on this slide reconstructs the condition of light and visibility at the time of the event. And you hardly can see Alderney and the islets west of Alderney. The pilot contacts the air traffic controller of the Jersey control zone. Until he loses the sight of the UAP, he exchanges information with him to try to identify the phenomenon. Better still, the controller involves other crews in flight to participate in this kind of hunting. On the slide, you can see in red the trajectory of the three-cylinder. Its call sign is AL544, AL for Origny lines. On the right of the slide, you see the radio calls. They are pointed at the trajectory point corresponding to the timing. All the dots on the map are the plot of detected objects based on the radar data recordings. The observation of the UAP lasts 12 minutes. All this time, the UAP is observed in the 12 o'clock of the Trislander, which means the 30 degrees angular sector centered on this longitudinal line of the aircraft. This sector is colored in beige on the drawing. The blue sector is the angular field of view of a passenger seated at the third row of seats who could see the UAP as the aircraft started the descent. So you see that the UAP is most of the time in the axis of the aircraft. This slide shows why the hunt for UAP was unsuccessful. The green circles points the spots where the controller had noticed remarkable radar returns. The green sectors indicate radar contact directions. This is given by the controller, of course. The beige sectors show direction of visual observation of UAP by the pilots. We clearly see that no radar detection can correspond to what the pilots see. Today, we could get the files of the radar detection recordings on the Channel Islands, and it was decided to resume the study using this data. So, the line of study consists in trying to establish a link between these recorded data and the geometric and kinematic data issued from visual observation of the UAP, and, if deemed relevant, to develop and study hypotheses for solutions. This is the map of the radar detections drawn up from the recordings. You can see the position of the radars involved. Guernsey radar is a primary radar. Jersey Airport radar, at the bottom of the slide, is a secondary radar, and Les Platons, bottom and right, has two radars, a primary and a secondary radar. What is a primary radar? It's a radar which operates in the basic mode of operation of radars. It gives the geographical position of the object it detects, but doesn't measure the altitude. A secondary radar allows an aircraft equipped with a transponder to send back information along with the return radar signal. This information includes its identity and altitude. This is very useful and very easy to use. To fully understand what we can get from the files and to know their limitations, it's necessary to explain how the system works. The first step in data processing is carried out at each of the radars. The return signal from the radar emission is analyzed and processed. The purpose is to sort out echoes of sufficient amplitude and to eliminate unwanted echoes. For example, rain, clouds, the effects of sea state. But also fixed or low-speed echoes, such as birds, by the Doppler-based process. Second step, the selected signals are converted to digital format. This allows the detection to be presented in the form of plots that are displayed on control screens and transmitted to other centers. On the Channel Islands, the detections of the 4 radars are transmitted to the Jersey Air Traffic Control Center. It's equipped with a special system, the Elvira system, which combines transmitted data, operates, and records them. So the air traffic controller can have a complete and clear picture of air situation in the area. We must know, it's very important, that in data processing, everything is done to optimize the detection of flying objects. In return, it's important to know that part of the data which are potentially useful for the European investigation is not recorded and no longer available. We cannot dispose of them. Let's now analyze the detection data. This is the map of the secondary detection. The secondary detection is the easiest to analyze. Indeed, in the files, data corresponding to the same IFF code can easily be selected. The IFF code is the identification code, which is transmitted by the transponder of equipped aircraft. They can easily be selected in the detection files and combined to form what we call tracks. You see these tracks, then there are these lines, straight or curved, on the map. On this slide, you can see 34 tracks with their associated IFF code. IFF means normally identification friend or foe, but for a civilian aircraft, but not a good thing, I think. Most of them are altitude international commercial flights. You see the lines going from southwest to northeast, joining, connecting Spain to Great Britain, for example. Others are local flights or connect Channel Islands with Great Britain. This is the case for AL544, which is coming from Southampton and intends to land at Alderney. We have two aircraft also important. This is Blue Island 832, which is mentioned in the testimonies, but it's not. It has a code 7770. It comes from the Isle of Man and intends to land at Jersey. And another one, which is, I don't remember, Flybe 912 Golf, BA146, departing Guernsey to Gatwick. You can see it from, with the code 3613. We have compared all the trajectories with the visual data from a geometric and kinematic point of view. None of these secondary tracks can match with what the witnesses saw. Though we can eliminate them, they are not good candidates to be the UAP. Now we have the maps of primary detection. I told you that we have two primary radars, one on Guernsey, which is on the left side of the slide, and the other one at Les Platons. This is the right side. You have, analyzing this detection, we have a lot of surprises. Guernsey plots are colored in gray and black. The black part is for the moment in the period where the UAP has been observed by the radar. The gray one is for all the rest of the time the data have been recorded. We have the same thing on the right side for Les Platons. The plots during the observation of the UAP are fully red. The other ones are brown. If we compare the two detection maps, we can see surprising differences which make uneasy the UAP investigation. On the right map, we can see Les Platons primary radar detection plots which are superimposed to the secondary plots. We can see the local flights such as IAL544 and other ones. They correspond, that is absolutely normal, to the secondary detection we have seen already. On the contrary, we have not that on the Guernsey plots map. Why? We don't know. We don't know the reason. We suppose that it's a matter of process of the Alvera system, but there is already a big difference, which makes that we're not sure what to be en confiance avec. Another thing, Guernsey radar seems to have a better detection performance than Les Platons. We have on the left map 58% more than the plots of the Les Platons on the right of the slide. Why such a difference? We don't know. Of course, both radars are of different types. The aerial turns at a different speed. It's 15 RPM for Guernsey and 10 RPM for the Platon. Maybe also we have different filtering processes in the both radar, but it's difficult to know. And we are sometimes, when we'll investigate the tracks, we'll see that something which is boring because we don't know what to trust. We have also investigated. There is a lot of island which can spoil the detection. Does the weather condition make some trouble for detecting? We don't know. We have still a big lot of work to do to investigate that. Here, they are the same maps. The trails we see on the north of the area are the train of boats which are sailing northeast on the ocean trail. It should be noted that these boats are far from both radars, about 70 kilometers from Guernsey and 80 kilometers from Des Platons. These boats are detected, despite they are beyond the detection horizon of both radars. Guernsey horizon, detection horizon is 44, 45 kilometers, and Les Platons 50 kilometers. Another strange point, you see the blue circle on the Guernsey map. It corresponds to the optical, this time, horizon of the Guernsey radar. And there seems to be very few Guernsey plots within the circle compared to the outside. Would there be any special software filtering? I don't know. We don't still have the answer to that question. In conclusion, we can only note that the detections of the two primary radars are very different, and we have to continue to investigate to determine the reason for this. We still have the same maps, and we are trying to construct the tracks for the primary detections. It's not so easy, as easy than for the secondary detection, because we don't know how to associate the different lines of the recorded data. When we look at the maps, we think it's reasonable to assume that plot alignments that we can see, they constitute tracks, but provided that the speed of the plots is consistent. That is, do the plots progress and sail and advance at the same speed, a regular speed, what we can calculate. So we had to apply a selection algorithm to the file for this purpose, and this way we have been able to identify 15 tracks that you can see here. We note that almost all of the trajectories are oriented approximately 030 or 210 degrees. The speeds that we can calculate also, the speeds spread from 11 to 50 knots. We have a lot of low speeds, which makes difficult to say if the mobiles are boats, microlights, or light aircraft. As already seen, these tracks have more Guernsey plots than Les Platons tracks. We looked at whether this could result from Doppler filtering. Doppler filtering is designed to eliminate fixed or very slow echoes based on the measurement of the relative speed target to the radar. However, this cannot be considered as the only or main reason. Let's have a look on some selected tracks that deserve to be examined closely. Okay. First, the P1 track. The P1 track looks strange with this line of little dots, which makes that we called the frog lips track because it looks like a frog has jumped over the sea from plot to plot. It's not plot, it's a pack of plots that we'll see on the next slide, please. It's a special case. It's an isolated case in the investigation. P1, the track P1 appears different from the other tracks due to the periodicity of appearance and disappearance of plot packs produced by both radars. Note that there is no synchronization. The duration of detection losses are different for two radars. You can see that on the graph at the bottom of the slide. Interval of plot absence come regularly. They last about 2 minutes for Guernsey and between 2 and 3 minutes for Les Platons. When plots are present, their density is high, and which looks very strange. Les Platons radar produces a plot at every turn of the aerial during almost 11 minutes since 1414. You see the graph at the right end. You see all these plots, and it's strange because we are far from the radar and we have a perfect detection of the mobile, but because we are sure there is a mobile at this time. We are still wondering what could have generated those phenomena which are specific to the P1 track. Does the target have rotating movements or climbs and descent? The question remains unresolved. Now we'll have a look on two other tracks. We have P2 and P5 in green. P2 is an imposing track by the profusion of Guernsey plots. We can see that already on the maps. And P5 is completely different. We'll see that it's perpendicular to all the trajectories. P2, we have measured the tracking 231 degrees and speed 17 knots. It's slow. P2 benefits from an abundant production of Guernsey radar plots. From 1333 to 1424, there are about 500 plots, while there are only 33 from Les Platons. The difference can be explained by the fact that the Guernsey radar is in the axis of the target trajectory, while the Platon radar sees the trajectory laterally. the relative speed is maximum for Guernsey, while it varies from +8 to -7 meters per second for Les Platons. As the Doppler process threshold is 4 meters per second, Les Platons eliminates a lot of plots. That's an explanation. P5 is tracking 110 degrees, and the speed measured and calculated is 150 knots. It's a maximum speed we could find in the investigation. It's perpendicular to all other tracks, and we note that there is no Les Platons plots in this track. We cannot see it very well on the slide. It appears very briefly, only 1 minute. It's a mystery. It's impossible to follow to find other plots which correspond to this P5. In any case, if we assume that the rest of the trajectory is in the extension of the track we have computed, it's impossible that this target stays in the 12 o'clock of the tree slender. P5 must be eliminated. We have compared the characteristic of all tracks with the data from the visual testimonies, timing, relative position in relation with the direction of observation. And we have only retained 5 tracks that you can see on this slide. The yellow part corresponds to the UAP visual observation period, the blue one for all the rest of this period. We then proceeded to a more in-depth geometrical analysis by calculating the relative bearing of the track plots as seen from the tree slender during a UAP visual observation period. The relative bearing is the angle found between the longitudinal axis of the aircraft and the direction of the distant point. The graph on this slide shows the relative bearing value as a function of time for each of the 5 selected tracks. But we have also the relative bearing of Alderney and Barrow Island, as they are taken as a visual reference by the witnesses. 2 tracks are remarkable, P2 and P11. The relative bearings are very faint for the whole duration of UAP visual observation. On the other hand, P1, P6, and P15, which are in the 10 degrees aperture angle from the tree slender at the beginning, then move away to deviate to more than 15 degrees from the tree slender axis. They get out of the visual cone of the 30 degrees of 12 o'clock. This is an animation, we say animation in French, at what we saw. We have 3 moments, different moments of the event, 1, 2, 3, and we can see the 5 tracks here on the point 1 at the moment of the ray Boyer sees the UAP. This is the position of the 5 tracks. The point 2, you see we have the history of the trajectory of each of the tracks. P2 and P11 stay just in the axis of the aircraft. On the point 3, they are still in the axis of the aircraft. Then we can see that P6, P15, and P1 are out of the 30 degrees angular sector. On the map, we have the trajectories of our best candidates, P2 and P11, And you can see two things. Bon, P2 stays on the sea. His speed is 11 knots. It's probably a boat. On the other hand, the P11, seems to cross the island of Stark. Sark is the island which is just east of Guernsey. Its speed is 23 knots. We think it's more of microlight. Maybe it goes to alternate for landing. It's close to the airport. The conclusions. The visualization of radar detections made it possible to identify two primary tracks of moving objects corresponding to the report of the witnesses. But we don't know for sure what these objects are and how they could have generated the visual phenomenon observed by the witnesses. The disparities and oddities observed in the detection display need to be studied more deeply. The analysis of the causes can provide us with other possible tracks and give us information about the object's nature and behavior. And finally, it should be remembered that all of research has focused on the study of tracks that represent only moving objects' trajectory. We must now consider the hypothesis of immobile objects, but the search will be difficult due to the fact that the filtering processes tend to make everything that does not move disappear. Thank you for your attention.
Okay, Jean-Marc, thank you for this excellent presentation, very accurate, very detailed, even if, of course, we don't have a clear conclusion for now regarding the correlation between the observation from the two aircraft and especially from the aircraft where Captain Rebo made the observation. We see that there are mainly two tracks, possible tracks based on the optical observation, visual observation, and based also on the motion of the plots. We don't know exactly if there are two tracks because Reboyer saw two objects, two phenomena. That's another question. And as you said, we still have to analyze the fixed plots pattern and possible track. So the hunt continues per se. Okay, I propose we move to the next presentation from Joshua Pierson, and we will keep some time probably at the end for some questions if there are.
Hello, I am Joshua Pierson. In this presentation, I will cover detectable signatures of unidentified airspace phenomena that emerged during my dissertation. Thank you for the opportunity to present today. My goal is to keep this presentation limited to approximately 30 minutes. In this presentation, I'll start with providing some background about myself, then go through the steps of the dissertation development. I'll address the problem I was attempting to solve and the purpose behind why I looked into this problem. We'll then touch on my research questions and move to the methodology overview. I'll spend some time in the methodology because it is arguably the most important element of the research process. The methodology will define how I collected, categorized, processed, and analyzed the data. We'll then move on to the findings and conclusions. I'll summarize recommendations to practitioners and academics and close with time for questions. A little bit of background about myself. I am the SCU National Security Advisor, and in that role, I look to inform and advise on the technical aspects of both disciplines of intelligence and national security, and the profession and community that is intelligence and national security. I am a career investigator of national security crimes and have 24 years in the intelligence and national security community. Here, I believe it is important to note that I am not an engineer, material scientist, or physicist. I do enjoy attempting to learn physics If my limited understanding of physics has taught me anything, it's that the more I learn, the less I know. It keeps things interesting. My education is geared around my chosen profession. I have a Bachelor's of Arts in Intelligence Studies, a Master's of Science in Strategic Security and Protection Management, and a doctorate degree in Strategic Security. My dissertation, which is the source of this presentation, was published in December 2023 and was the final requirement for the completion of the doctorate program. Here we discuss what is the problem that I am trying to solve. During the development of the problem statement, I leaned heavily on my experience and educational background to determine what is the problem and what techniques are available to solve it. As I explored the literature on the topic and conversed with those who have decades of experience looking into this topic, I learned 3 key points. First, UAP penetrate sovereign airspace and sea space with impunity. We can do nothing to stop the phenomenon from moving in and out of sovereign domains. Second, the science and government communities are not in sync on looking at this topic. We don't really know if UAP present a public policy or national security problem. Governments historically cannot look at highly technical issues like UAP on their own. They need the private sector to help bolster their capabilities. Third, since UAP is phenomenological and can't be recreated in a lab, it presents a rich condition for using structured analytic techniques for intelligence analysis. At its foundation, a structured analytic technique is a scientific process. We'll look more into this on future slides. Looking at whether UAP present a national security or public policy problem, we must start with understanding how threat is defined in the intelligence and national security community. Threat requires understanding the capability of the adversary. Capability are those things that can be done, or the power is present to do them. Intent is the desire to use that power against a target. Action is the employment of capabilities against a target. Therefore, I focused my efforts on attempting to identify those signatures which point to capabilities. I initially attempted to focus on intent, but changed focus from that particular element of determining threat. Although there is potential to use the research model to identify and analyze intent, that analysis is not a focus for this research project, which I'll address more on that point later in the presentation. Moving on to the purpose of this research project. Looking back into past UAP research, we see an effort to collect testimonies and catalog them into databases for possible future analysis. However, often the source of the information is subjected to such scrutiny that most testimonies are ruled out or the testimonies are nonsensical and do not lend themselves to analysis. One key point that Jacques Vallée articulated in many of his works was the absolute need to go to the primary source and get the story. Within the domain of intelligence, we also place special emphasis on the need to find primary sources for inquiry. I was not in a position to be able to do such diligence. Instead, I used Vallée's point and my experience and built a curation standard around identifying those source testimonies where I could determine if the testimony originated from a primary source. So what did I do? I surveyed current databases and references to find those testimonies. I then categorized those, meeting a curation standard which I developed, and applied analytical tradecraft to the data collected. My goal was to enrich available data sets on the phenomena. I sought those testimonies that provided signature criteria in which I could identify a pattern and commonalities. The signature must be both observable and detectable, meaning that the source must engage their senses to experience the encounter, and that the signature lends itself to possible technical collection or an application of a technical skill to capture and analyze the data. Using my curation model, I looked at observations already reported and available from 16 references of UAP testimonies, reports, and cases. How I did it was through a 6-step curation methodology, described in subsequent slides, then sorted the testimony into 3 categories. Category 1, testimony, a declaration of a phenomenological event that the witness believes to be true. Category 2, an account of a phenomenological encounter in written form. And Category 3, cases, defined as a phenomenological event in written or printed form that warrants further study or investigation. I then excluded those based on the criteria derived from my curation standards, annotated it in my reference matrix, and then analyzed those signatures reported most often. My delimiting factors were that I conducted no interviews and used only publicly available information. I did not submit for an IRB review in the interest of time and the presence of many UAP references of testimonies and reports already publicly available. I also required that each testimony had to have at least 2 sources to meet initial standards for possible inclusion in the data analysis. I derived the definition of source from the U.S. National Security Standard. The definition is a person, image, signal, document, database, and communication capable of providing intelligence information through collection and analysis. In this vein, cases were included in the data analysis survey that encompassed one individual and evidence of the presence of a UAP encounter after the encounter occurred. So as an example, in one case, there was only one witness who was a pilot. The pilot observed the UAP but did not get a radar return. However, when he landed, he observed a substance on his wing and the wing glowed a greenish hue. The presence of the greenish hue on the wing and the correlation of the presence and observation of a UAP means that the green glow on the wing makes the wing a source of information which, if gathered, can be analyzed by intelligence disciplines or other scientific efforts. My objective was to determine if common measurement data or technical signatures exist among multiple UAP encounters. I used the National Security Industry Standard for the definition of signature, which is identified as the measurement of the strength, intensity, or state of some physical quantity over space, time, and/or frequency. With this definition as the point of departure, my approach was more liberal on attempting to discern a signature because analysis into UAP is lacking a profile for what exactly is a UAP. Looking at a brief history of UAP, the common consensus in the U.S. is the first report of UAP occurred in 1947 by Kenneth Arnold. Research into the topic highlighted that the first agreed upon UAP encounter occurred during World War II. These encounters were consistently reported, leading to Project Sign, Grudge, and Blue Book. All of these were USAF programs. In 1969, with the publishing of the Condon Report, it led to the end of meaningful academic and government study into UAP. UAP research groups then stepped in to try and continue research. From the late 60s until about 2004, research was conducted by UAP study groups who developed databases and research tools to try and categorize UAP. After 2004 until present, access to UAP information increased exponentially. Research did not keep up with that access. At this time, most cases are pithy 3 to 5 line statements that require curation to determine credibility and reliability. It is due to these gaps in reporting that I had to open the aperture to include a wide sample. The history of UAP research indicates at a minimum that capturing data that defines a signature lacked diligence. This presentation doesn't focus on this indication. Instead, it's because of this indication that I sought to answer the research question. Sub-question 1 could not be answered. We just don't have the data to answer if there is an environmental effect on the observation of UAP. Anecdotal reports exist that indicate a possible extreme weather change after the presence of a UAP, but these are not cataloged in any manner that opens the aperture for proper analysis. Sub-question 2, in my opinion, was definitively answered, as we will see as we move on through this presentation. The methodology overview addresses the process by which I conducted data collection and analysis. If I could orient you to the graphic with the title stating, Common Process for Documenting UAP Events. This process is the current method that leaves UAP databases rife with 3 to 5 line statements that are often devoid of any useful information. The process is short. An encounter occurs and the witness testifies to it. The witness publishes the testimony, often independently, into one of the main UAP databases, which are MUFON and NUFORT, and no scrutiny is applied to the testimony. I'd like to take pause here and say that this is not because of a lack of desire to apply that scrutiny. There's just too many reports for the group of people looking into those reports to apply scrutiny to reach a point to identify cases that need further review. In an effort to determine the most feasible means of gathering information from witnesses and to identify those testimonies that I could classify as a case, I examined testimonies through the 16 references. Included in these references are the NICAP chronology and UFO casebook. NUFORT and MUFON were not usable for this project because there's no standard on what is required to submit a UAP testimony. The lack of a reporting standard leads to a degradation of analysis when anyone attempts to conduct meaningful research into the phenomenon. I identified those cases where I could assess source credibility through the curation standard, and those were documented into my data matrix. During the course of this project, I ran 2 separate databases. One database captured the reference material used, and I sorted them by case number and exclusionary criteria. The second database was the UAP case matrix, which captured the cases and signatures associated with the encounter. It also captured source credibility and method of observation. My curation standard encompassed 6 steps. The reports had to have common signatures with those encounters that are reported at national security sites or with national security artifacts. I initially focused my research efforts on encounters with national security artifacts and sites, but quickly realized that my database would do two things. First, it would implement a confirmation bias that UAP are significantly interested in national security, and second, be limited in accurate and comparable data of UAP encounters over space and time. The presence of two separate sources coupled with the testimony of three signatures was a basis for establishing credibility. I then scaled credibility based on the professional criteria of the source. What was the source's professional background? Was a source a pilot or military? Was the source a national security or law enforcement employee or agent? Or were they a general civilian eyewitness? The case then had to have an approximate time and date, which must be able to place it in space and time. The source had to provide at least the month and year of the encounter. Lastly, using Dr. J. Allen Hynek's Close Encounter Protocol, with Close Encounter 1 being an observation of a UAP event, Close Encounter 2 being physiological traces left by a UAP encounter, and Close Encounter 3 being those encounters with biologics, I limited my study to only Close Encounter 1 and Close Encounter 2. The reason I limited it to these two is that academia as an institution is not ready to expand research efforts into CE3. Interestingly enough, the people in academia are, but the institution of academia not so much. My future plan for my curation method is to open the aperture to include single source reports in CE3 cases. I'll develop my criteria for assessing a single source report and move forward with researching this topic again. Moving forward on this slide, after data collection, I then applied structured analytic techniques for intelligence analysis. I used analysis for competing hypotheses to determine if we have evidence for possible origination of UAP, and then attempted to apply scenarios and indications. I was unsuccessful at applying scenarios and indications analysis to the dataset for two reasons. First, scenarios and indications requires intent to determine what the actions of the studied entity indicate, and intent is based in rational choice theory. Rational choice theory requires an analysis of behavioral characteristics, which this study was not poised to answer. The second reason is determining intent is rarely conducted by one person. In the national security community, when attempting to build a scenarios and indications analytical product, often the primary analyst is corralling other analysts to argue it out. A good example of this type of study happening in real time is the SCU Pattern Analysis and Intention Study, which is currently developing paper 4, titled UAP Indications Analysis from 1945 to 1975, Military and Public Activities. I am fortunate to be a member of the team that is developing this groundbreaking effort. Moving on to slide 8, we see the actual process used to determine which testimonies met curation standards. Starting on the left with the 4 steps, I began by assessing the testimonies derived from 16 references. I reviewed approximately 20,000 testimonies and surveyed these testimonies that occurred between 1942 and 2021. This number can seem hyperbolic, but given the databases of UAP testimonies and reference used, I can assure you it is not. In a recent article that was published in Nature Portfolio in their scientific report section titled An Environmental Analysis of Public UAP Sightings and Sky View Potential, plotted 129,949 UAP reports from the New Fork database on a map. I then assessed these 20,000 testimonies that presented at least 2 sources and 3 signatures. If they presented these 2 sources and 3 signatures, I classified them for review and found that 2,368 warranted further review. I then excluded 1,684 for various reasons discussed in future slides. 684 cases met curation standards. I then added these cases to a reference list. The reference database included a case number, reference number, and which testimonies, reports, and cases were included and excluded. I then sorted the cases by reference and offered exclusionary criteria if they were excluded. During the curation review, I annotated the reason for exclusion. For those that were included, I extracted the signatures and added them to the case matrix. I used notebooks to capture the signature. Lastly, the signature data matrix informed my analysis. Analysis provided graphs and pie charts, a map and comparative analysis, which developed profile groups. On the right is the flowchart for the process. As I've already talked through these on the left, I'll pause so the audience can review. Moving on to the next slide, we see the references I surveyed on the left and the exclusionary criteria on the right. On the left, I sorted these references by author, the number of reports extracted from the references, and how many of the reports met the criteria for analysis and labeled as cases. The last sorting category are those cases which were excluded. Looking at Clark's references, labeled Clark, Jerome, this reference is a UAP encyclopedia. From that reference, I found 170 reports of UAP encounters. 84 met curation standards and were included in the data analysis, and 86 did not and were excluded. Not depicted in this presentation is the database of those reports from Clark's work. In that database, I gave the page number so we can locate the report and the report number I assigned. I can provide a presentation specifically on the curation and cataloging methodology upon request. Moving to the right, we see the exclusionary criteria. Instead of going through each of these as they are rather self-explanatory, I would like to draw your attention to CE3 encounter, of which there were 75 reports. Each of these reports would have been included in the database if academia were ready for me to catalog these results. Another concern with CE3 encounters that was addressed by my committee was that I may need an IRB review to include CE3 encounters since a human subject is present. Although the data is publicly available, the lack of an IRB review may cause consternation, so we chose to avoid it altogether. However, in future studies, I plan on expanding the parameter of my curation standard and including CE3 cases. As I was doing the research, I could see the relationship between UAP and CE3 emerging, but had to eliminate them for this study so I could get the paper approved. Again, I'd like to reiterate that my committee was open to the idea, but given that I didn't have an approved IRB and we weren't sure how it would be received once published, I opted for a conservative approach. This slide depicts the analysis methodology I developed for analyzing UAP signatures. Starting on the left, I used a funnel model as my approach. I gathered all signatures and organized those signatures into 5 profile groups. On the right, we see the 5 profile groups. I attempted to place signatures with common characteristics into the specified profile group. I then compared all the profile groups to the shape signature. The shape signature was the most commonly reported signature at 539. I then looked for relationships between the profile groups and the shape signature. I had 12 different types of shapes reported, which were disc, triangle, sphere, circle, trapezoid, delta, cylinder, diamond, cube, cigar, square, and rectangle. Being that the data set did not offer itself to meaningful analysis when looking at 12 shapes, I classified these observed shapes into categories which were most relatable. Triangles were reported 184 times. Discs were reported 152 times. Spheres were reported 107 times. Cigars were reported 83 times. And all other shapes were reported 52 times. Of special note, all other shapes were then converted to combined shapes category when doing data analysis. Discs included circles, triangles included deltas, combined shape category included cigars, spheres, cylinders, diamonds, cubes, squares, and rectangles. When looking at the combined shape category, when broken out amongst the 12 separate shapes, I attempted to compare the profile groups to 4 shapes initially. These 4 shapes were triangle, disc, cigar, and sphere. However, when comparing cigars and spheres separately, I didn't have enough data to assess a profile for those particular shapes. I then combined cigars, spheres, and others into a combined shape category because when combined, the data was substantial and could provide a profile by which to compare future studies. After categorizing shapes, I then compared profile groups to the shape categories, depicted on the right in the red text box. After the comparison, I developed profile statements and plotted the reports on a map. The map graphic is not included in this presentation. This slide depicts the 7 findings that were the result of analysis. Finding 1 is simple. People are observing UAP and can report on these encounters. Encounters are observed through unaided and aided means. Secondary to this finding, technical methods of collection most frequently validated unaided observed UAP encounters. In only a few instances was the encounter documented through a technical collection device before observation. Finding 2 informs us that UAP encounters most frequently occur at night, and coupled with finding 3, we see the most common duration for UAP encounters occurs between 1 minute and 59 minutes. This finding further substantiates UAP as an actual event when observed. Considering the perspective of a law enforcement officer talking to a witness, often the witness can only provide an observation that ranges for a few seconds because a suspect is attempting to evade observation. However, reporting and analysis indicates that UAP remain within an observable range for a period of time where the witness can sort and categorize the observation. In finding 4, we learned that UAP encounters are observed by a diverse population. Population diversity is important to inoculating against the belief that a collective pathology is present. Finding 5 is substantial. Throughout the literature review in the course of the project, the commonly held belief is that UAP has a relationship with a substantial presence at national security locations or interacting with national security artifacts. Finding 5 indicates otherwise. Reasons for this finding could be the restrictive nature of the applied curation standard or the length of time I used for my UAP dataset. I'd be remiss if I did not recognize that over the course of the decades, UAP presence at national security sites occurred frequently. However, UAP encounters do not only occur at national security sites, but is a global phenomenon. When looking at finding 6, I used U.S. government publicly available information to determine what were the proposed 12 signatures that were most observable. Those 12 were not the most collected or reported. Although this finding may only indicate a gap in data collection, it is key in helping to refine data collection efforts and interview techniques. Closing out my findings, I won't spend much time explaining the analysis of competing hypotheses structured analytic technique, other than to state it is a model to apply a numerical value to evidence and weigh it against hypotheses. For this study, I developed 4 scenarios and weighed the evidence against the 4 scenario outcomes. The table of outcomes is provided as a hidden slide for review by the attendees. When reviewing ACH, I discovered the need for a null hypothesis with my committee. We collectively decided that in this project, a null hypothesis was not needed because this project is seminal in its attempt to classify and categorize UAP signatures and their relationships. The evidence strongly indicates outcome 4. Based on this finding, it is possible that the evidence indicates that UAP may be conducting a general survey. However, being that this project is not designed to focus on intent, I'm going to stop here with possible intention assessments. The graphic depicted on this slide is here for the attendees to take some time to review all the signatures reported and cataloged from the data and how many times the signature was reported. 42 signatures emerged. These signatures and attributes were stored into the profile groups and then compared to shape categories. The subsequent slides are a picture of those signatures and attributes most often reported with UAP. This slide depicts what signatures are most reported amongst the entire data set. When we say UAP, this slide depicts what we mean. These signatures are most commonly reported across all UAP cases analyzed for this project. Please take some time to review this slide. As you're reviewing, you'll see red circles and blue circles. The red circles are the primary description of the signature. The blue are the secondary description. So when someone says shape was observed, the type of shape becomes a secondary element that is reported, which in the case of shape on this slide, the secondary elements are triangles, discs, spheres, and cigars. On this slide, we see what is most commonly associated with the triangle UAP. The triangle was reported 184 times, and 3 findings emerged. First, the first triangle case occurred in the early 1940s. Only a few more occurred until the late 1960s, which there was a notable increase, which stayed in double digits over 5-year increments. Second, the triangle went through updates. It originated as a solid gray to matte black, thick, full triangular object, then a delta wing along with the full triangle, and then moved to having a grid-like structure with fluid moving through it. Third, it doesn't appear to be transmedium. Instead, it deploys transmedium objects. I didn't come across one report where the triangle was observed entering space or entering the ocean. Instead, silence, low observability, and stasis to speed momentum were the most frequently reported signatures. The triangle appears as though it went through a development process that can be observed, cataloged, and tracked, much like a research and development project. The disc shape was reported 140 times and was most associated with transmedium capability, emitting a sound, and having a negative response to the observer. Discs like to hang around, with the most common duration occurring between 15 and 30 minutes. Discs are associated with the Colares event in Brazil in the 1970s and appear to leave a negative physiological response. Although we cannot measure the signature that may have caused the impact on livelihood, we can measure the effects of the signature on the affected population. Based on the reporting metrics, I combined the other shapes into one category to build an effective understanding of what signatures and the various other shapes exhibit. These shapes range from spheres, cones, and cigars to trapezoids, squares, and cubes. An interesting finding that emerged is that cones and trapezoids were deployed and embedded in the Earth. Study into these locations did not reveal any objects embedding in the Earth, however. Shapes in this category managed to move from stasis to speed and present in locations that are not aligned to current understanding of physics. Analysis of reporting indicates that these shapes could be observed in the sky and in a manner of incomprehensible time be in a vehicle. Reaching the conclusion slide, we see that 8 emerged. Being that we've covered most of these during the presentation, I'm going to address an incongruence in conclusion 8. Conclusion 8 states that UAP are transient, but anecdotal evidence points to cluster areas. The possibility exists that my curation standard was conservative and ruled out key data that would indicate either that UAP is transient or that UAP appears in cluster areas. Another reason for this possible discrepancy is that we don't have a good idea of what a cluster area is. Often reporting leaves gaps in the exact location of UAP, and we are left to guess based on what is available in the UAP data sets. Future studies and collection efforts can address this gap and get to the granularity of where UAP appears so we can analyze if cluster areas exist. Until then, we are in a position to state that UAP is transient and global, but may cluster in certain areas. An integral point emerged during this project. We have a lot of data, but we don't necessarily have good data. So the focus of my recommendations to practitioners is on how we collect better data. In the appendix of my dissertation, I have 3 types of reports and the purpose of using each of them. The objective is to refine data collection into a standard that the community can accept. The goal is to move away from the constant issues with information veracity and source credibility and focus on factual accuracy of collected information. The better the data collected, the better opportunity we have for effective analysis. On the left of the depicted slide, the recommendations are in 5 steps. On the right is the flowchart of data collection. When an observer reports an event, an investigator can interview and collect the evidence. After the interview, the investigator writes 3 reports. The first is an informational report, which discusses the factual accuracy of the event. It provides the facts as stated by the observer. Afterwards, they develop an operational report. This report is a narrative where we learn about the mechanics of the meeting, who the source is, why they're reporting, and about their overall demeanor. The third is the report of all collected evidence. We document what we collect, and we maintain a chain of control so we don't lose the evidence. We can then use the data collected to analyze UAP encounters through various different processes, refine the effort, and then determine where we can put a multimodal sensor array once we identify cluster areas. Also, when reviewing the reporting templates in the dissertation, we can use those reports for reporting encounters into databases. Those wishing to make a report can just fill out the information report and an operations report so we have a standardized format that captures UAP data. The database controller can then triage the reports and determine which ones require follow-up and then dispatch a team. I have 4 recommendations to researchers. In future reporting and analysis, we need to identify signatures across time, location, and the duration of the signature. Doing so will help future UAP research efforts to accurately identify and define the measurability of the reported signatures. We need to incorporate the human sensor into the scientific process and analysis. The analysis in this project indicates that UAP linger in areas long enough for a person to sort, categorize, and classify the encounter in their head and then regurgitate their observations in either a report or to an information collector. We should apply structured analytic techniques to UAP data evaluation. UAP are phenomenological events and can't be recreated in a lab. We have limited capacity to apply a scientific method. Instead, we should focus on a scientific process where our logical sequence can be replicated. We aren't always going to be able to start with a hypothesis when studying the phenomena. UAP study groups are best poised to adopt a UAP information gathering and analysis strategy. If we tighten up our data collection and come to an agreed upon standard of information collection, we'll see the dividends in future UAP research. As I wrap up, I would like to state that UAP execute activities with impunity in U.S. and in other nation states' airspace and sea space. This research project sought to survey, analyze, and enrich UAP datasets by applying a curation standard using only publicly available information. UAP encounters occur ubiquitously and frequently. People from all walks of life encounter them. The phenomenon can be studied and detected. Using a multimodal sensor array coupled with the human sensor is our best avenue to attempting to understand this enigmatic problem. This concludes my presentation. Thank you for attending.
Thank you, Joshua, for this very complete presentation on methodology and signature characterization and so on. We need certainly to revisit this slowly because there are a lot of information inside. I propose now to move to the next presentation. This next presentation is about the Stephenville UAP case. Robert Powell and Sarah Little both worked on this presentation for us. Thank you.
Hello, everyone. This is Robert Powell. I'm going to be talking to you today about the Stephenville lights. This is a paper that I completed 16 years ago, and I was also involved in the actual interviews of the witnesses as well as the analysis of the radar data. This is a comprehensive radar and witness report study regarding the events of January 8th, 2008. And it takes place between 6 and 9:30 in the evening. And the other gentleman who was part of the paper with me was Glenn Schultz. Next slide. Glenn, and I know this is probably hard for you to read this, but Glenn Schultz was a radar Army engineer, and he had actually done radar analysis. If some of you may remember the TWA flight that crashed as it was flying from New York City to Paris. He did analysis of that flight using radar data. So Glenn, and had worked with the Army, was very knowledgeable of radar analysis. So he worked with me in the analysis of the Stephenville radar data that we obtained. Next slide. But first, let me tell you just a little bit about SCU, which is the organization I'm an executive board member of and I represent. It's a 501c3, which means it's a nonprofit organization in the United States. We have over 300 members. Those comprise scientists, engineers, mostly people with science-type backgrounds. Over 30% of our membership have PhDs, and over half of the membership have either master's degrees or PhDs, and 20% of our membership is outside of the United States. Next slide. So I want to begin talking to you about the Stephenville case by looking at three basic areas. First, I just want to make you familiar with the geographical area. Second, I want to make you familiar with the history of UFO reports in that specific area. And third, I want to discuss a little bit about the uniqueness of the incident. Next slide. This is a map of the area of Stephenville. If you look at the bottom left corner of that map, you'll see the city of Stephenville. It's a population of about 17,000. It's a small town. To the upper right, you see the Dallas-Fort Worth Metroplex. That's one of the largest metropolitan areas in the United States. Stephenville is about 70 miles directly southwest of that metropolitan area. In the western part of that metropolitan area is a military air base, formerly known as Carswell Air Force Base. And that is where the jets involved in this incident that I'll talk to you about originated from. Next slide. This is just a typical view of the terrain in the Stephenville area. This area is approximately 1,300 feet above sea level, and it's kind of a flat plateau-like area. As you can see, there are trees there, but it's not heavily treed. It's mostly plateau. Next slide. This gives you a little bit larger map. Again, you see the Dallas-Fort Worth area in the upper right. The red line that you see is the path that F-16s take from their military base to a military operating area, which is simply an area where they practice military flights. You can see in the lower left, the military operating area. It's known as Brownwood MOA. And that's approximately a 70 to 90 mile flight from their air base to that area. And you can see that it flies right over the city of Stephenville. They fly this route approximately 3 to 4 times a week. So it's not unusual. The residents of the city, they see F-16s fly over their city all the time. So seeing an F-16 is nothing unusual to the residents of Stephenville. And you can see in the subtitle, Carswell Air Force Base is now called a new name, which is NASJRB. It's basically now a joint Air Force, Marine, Navy base. Next slide. Now, this is to give you a general idea of UFO sighting reports as they occurred prior to the January 2008 incident and as it occurred later. What I'm trying to get across with this slide is that something unusual happened in the year 2008. And it wasn't just people imagining that they saw things, right? So if you look at the lower left, on the left side of that graph, you'll see what it was like during the years 2005, 6, and 7. The orange bar tells you what the normal number of reports would be for an area in Texas of that population size, right? Because normally the more the population, the more the reports. So you can see when you get to the year 2007, it begins to shift away from the norm because the blue line, the blue bar represents what was actually reported in the county of Stephenville. And the orange is what should be expected, right? So you can see it began in 2007. 2008, you have a huge spike, and that's basically reports from the month of January when the Stephenville event occurred. And then 2009, you can see it drop back down, which this is normal when you have a flap, right? Because a lot of people hear about it, so then they begin to report. So you have reports going into 2009, but the actual event was 2008, the large blue bar. And now if you look farther into the future for the years 2010, 11, and 12, you can see that the reporting level in Stephenville, which is represented by the dark blue, is now pretty much the same as what would be expected, which are the orange bars. Next slide. In this slide, I want to emphasize how unique the Stephenville incident is. I look at witness reports in 3 categories. I call category 1 is you either have a single witness or you have 2 related parties, right, that see a UFO. So this means the individuals know each other. They're there at the same point in time, right? So this is kind of a typical UFO report. Now, a little bit better report is what I call category 2. You have not only multiple witnesses, but all the witnesses don't know each other. That's important because that helps eliminate prejudice from people talking to each other. So in this incident, you've got different people, but the UFO incident is still a specific point in time in a specific geographic area. Now, category 3 is what I consider the very best of all. In this, not only do you have multiple witnesses, but it occurs over multiple points in time and various geographical areas within a confined geographic area. For example, some of you may be familiar with the Levelland reports that happened back in 1957, right? You've got different witnesses that don't know each other. You've got a specific geographic area, but the sighting reports are being made in different parts of that geographic area, and it's over a varied period of time. The reason these reports are important is, one, it eliminates witness prejudice. Number 2, it eliminates misidentification of a specific object at a specific point in time. So that's the value in category 3, and that's what the Stephenville report is. A more recent type of report that some of you may be familiar with would be the 2004 Emmets report involving the USS Nimitz, because again, there it takes place over a varied period of time, 4 hours, and it takes place within a specific area, the Southwest Pacific, but in different points there. So that is what makes a really good witness case. Next slide. So for the Stephenville incident, I'm going to go through the data sources that I obtained, chronological order of the witness events, and then I want to show you radar confirmation of what the witnesses reported. And then I'm going to go through 2 examples of high acceleration that was detected with the radar. So not only did the radar confirm what the witnesses said, the radar established some acceleration values that current known technological aircraft cannot meet. Next slide. So here's where all the data came from for this case. First, from the witnesses, we had over 20 witness reports, different witnesses that came in within the very first week of the event. That is a lot of witnesses, and all of the witnesses that could be interviewed were interviewed. And I personally interviewed the key witnesses in this case. The second source of data were Freedom of Information requests, which in the United States, this allows us to ask a government organization for information. So the basic government organizations I sent these FOIA requests to were military bases and the FAA. The military bases, even though they had radar systems and were very close to where all of this occurred, all gave me the same reply, which was, and this is a quote that they all used, "We have no information responsive to your request." Again, it was, "We have no information responsive to your request." Now, what that means exactly, who knows? That's a very generic type statement. But I did get a response back from the FAA, and we received a lot of FAA radar data, which is in point number 4 there, from 5 different radar sites. And the third point was I also sent FOIA requests to various Texas law enforcement agencies, and nothing really came out of that part. Next slide. So the very first beginning of the Stephenville event was between 6:10 and 6:15 p.m. At that point in time, the sun has already set, but the stars are not out, so there's still light in the sky. The very first witness is a truck driver who's to the east of Stephenville, and he's driving towards the city, and he sees 2 very bright lights that are together in a stationary position. And as he described them, they suddenly just moved apart at just an extreme speed and disappeared. And that was all he saw. Meanwhile, in the same direction he was looking, there were 4 witnesses in a farming community, one of whom was a private pilot, who saw 4 bright lights moving at extreme speed coming from the north and northeast. They saw them slow down, come to a halt. The lights changed from a horizontal to a vertical formation, and they emit basically what appeared to be a flame, and then they disappeared. Next slide. Now we move forward an hour, and there are more witness sightings in between these times, but because of the time we have allowed, I'm concentrating on the most important sightings. So at 7:20, the skies now, it's almost an hour later, they're now completely dark and the stars are out. The county constable lives in the city of Dublin, which is 10 miles southwest of Stephenville. So this is in the same general geographic area. He's outside and he sees slow-moving reddish-orange lights to the south of his home. He doesn't know what they are, so he goes into his home to get his wife because he wants her to see what he's looking at. His wife is watching her favorite TV show, and she tells her husband, "I don't care about UFOs. I'm not leaving the couch." So he goes, and his 9-year-old son happens to be there, and he says, "Dad, I'd like to see them." So the constable goes back outside with his 9-year-old son. Now, the lights are no longer south of his home, but they're more kind of above and higher up, and they're moving around in a random fashion. And then suddenly, these random moving lights come together synchronously and move in tandem to the north-northeast towards Stephenville. At about that same time, there is a policeman in Stephenville who reports seeing a strange object within the city of Stephenville, and he draws his view of the object, which is on the next slide. This is what the policeman drew that he saw. He described this object as almost a city block across, and the object initially was in a horizontal position. He used his radar gun to clock the object because it was slowly moving away from him, and it was moving at 27 miles an hour, according to his radar gun. As the object began to move, it went to a vertical position, but using this pin to show you, it didn't turn off its center of axis. It's actually pivoted from the side of the object and then moved off vertically, which is totally non-aerodynamic, but that's what the policeman described. Next slide. So now what I want to show you, we obtained the radar data. So now let's look at confirmation of what the witnesses reported to us. This slide just is one of 5 radar sites where we obtained information. What you're looking at is a geographic area about the size of Great Britain. So this is a lot of radar data that covers a huge area of the country. Every one of those blue dots that you see is a specific radar track that was received. The radar is rotating every 10 seconds. And within this area, you've got commercial aircraft, you have, small civilian aircraft, military jets, and you have the unknowns that we detected. But the purpose here is just to give you an idea of the amount of data that we obtained from these 5 radar sites. This is probably the only time in the study of UFOs in the United States where we've gotten this much radar data. Today, it's much more difficult to get that information from the FAA. Next slide. The first thing I did when I analyzed the radar data is I wanted to verify that our analysis was correct. The best way to do that was to track the F-16s before you worry about UFOs, right? So I used the radar data, and I was able to track the flights, and the F-16s would fly down in squadrons of 4 jets at a time. And the way that works in the United States, and this is important to understand, is that one of your 4 jets must use a transponder, which is basically a radio signal that goes to the radar system, right? It's what every commercial jet uses. And it basically is a code that says, this is my altitude, this is my speed, and this is the identification of my aircraft. So your lead jet, when you're flying through civilian airspace, must do that, right, in order to avoid conflicts with commercial aircraft. Now, your other 3 jets are not required to do that. So they're flying without any transponder signal, which means the only way you can detect those 3 jets is through primary radar. Primary radar is what you normally think of radar. You have a radar beam that hits the aircraft and bounces off the aircraft back to the radar. So for 3 of the 4 F-16s, that's the only way to detect them. So this was excellent verification that we could use the radar data to track objects that did not have transponders, right? Because a UFO is not going to have a transponder. So we tracked those coming out of Fort Worth, moving down towards the military operating area, and we could track the jets that did not have transponders, as well as the lead jet, of course, which was easy to track because he did have a transponder. Next slide. I'm going to speed up because I'm beginning to run out of time, but this are the witnesses that I talked to you about between 6 and 6:15 p.m. We got actually only 2 radar points for their observation. And if you look at the upper center of that graph, you see an arrow moving to the upper left. And that was the 2 data points we had. And those data points align in time and location and direction with what the witnesses reported. Now, the only problem is we only have 2 data points, right? And although it's not likely that that just happened to show up at the right geographic and time and point in time, it's still, in my mind, not totally sufficient because it's only 2 data points. Next slide. Now, this is the constable. Remember the constable went out with his son and saw the object south of his home? This is amazing how this lined up. If you look at this graph, you will see Dublin, Texas, which is at the very upper top part of the screen. The witness lives a little southwest of town. And just as he described, at the same time that he said this happened, you see on radar to the south of the witness, and that's 2 miles south of that witness, objects that are basically moving very slowly, and they're showing up on radar. Now, as time's moving along, you see suddenly this object move to the north at an extreme rate of speed. The calculated speed there was around 2,000 miles per hour. And then it disappears off radar for a minute or 2, and then it shows up again back to where it was moving along. So this was excellent confirmation of where the witness sees the object south of his home, that's on radar, and then a sudden movement to the north that he described with his son, where the objects moved in tandem at an extreme rate of speed, that shows up on radar. Next slide. And this is an object that was tracked on radar with 187 tracks on radar. And you can see that's a line. Those are not random points. That is a definite object. And there's no transponder. This is a unidentified object. And it's actually moving towards a Crawford Ranch, which was where the president used to be when he was not at the White House. On this day, he was not there, but nonetheless, that is still a classified airspace. What's interesting here is we have an object that suddenly moved from 24 miles an hour up to over 300 miles an hour and then 500 miles an hour before, within 10 seconds, slowing from over 500 miles an hour to 49 miles per hour. And bear in mind, we know that what we're seeing is real because we track the F-16s. We know the radar data is reliable, that it can determine speed as well as location. Next slide. Okay, now I want to talk about 2 cases where I calculated the acceleration. The first slide here is the one you just saw, right, with the 187 tracks. It's a linear path going from the northwest to the southeast. The average speed across those 187 tracks, right? And remember, you get a track every 10 seconds as the radar rotates. That average speed was 45 miles per hour over 1 hour and 8 minutes. All right, now these specific times that I'm showing you, for example, in the very first one, it says it was 7:31 p.m. and 41 seconds, right? And based on where it was, its latitude, longitude, coordinate 10 seconds earlier, its speed was 24 miles an hour. 10 seconds later, the radar rotates. It's now 7:31 and 51 seconds. The speed is now 391 miles an hour. Another 10 seconds, it's 7:32, or actually 20 seconds, 7:32 and 11 seconds. The speed is decreased to 244 miles per hour. 10 seconds later, it's 7:32 and 21 seconds. The speed is now 536 miles an hour. And 10 seconds after that, the speed drops to 49 miles per hour. Using basic acceleration formula, calculating linear acceleration, the g-forces, especially when it went from 536 to 49, was a minimum of 2.2 g-forces. The reason I say minimum is the radar only rotates every 10 seconds. It could have decelerated in 5 seconds or 1 second. We don't know, because all we know is that at least within 10 seconds, it had dropped to that speed. So that means the minimum g-forces were 2.2. To give you a reference, an F-35, which had just been developed by the year 2008, in terms of linear acceleration, can only accelerate it up to 1.7 Gs, right? So technically, it might be able to accelerate linearly to the numbers you're seeing here. The problem is it could not have traveled 1 hour and 8 minutes at a speed of only 45 miles per hour on average. The reason, the record for an F-35 to hover is only 10 minutes because it uses a huge amount of fuel, and there's no way we have any craft that can travel at low speeds and then suddenly accelerate with those type of g-forces and then decelerate again. Next slide. This is my next to last slide, and this is probably the most important one. Remember the constable when he sees the object move to the north suddenly, and we detect that on radar. We have 25 tracks on that object. The sudden movement to the north, which was a minimum velocity of 2,018 miles an hour, because it rotates every 10 seconds. It could have gotten there sooner. To move that fast from 0 to 2018 in 10 seconds is a minimum of 9.2 g-forces. We have no craft that can linearly accelerate. We have accelerations that are due to tangential movement, right? Due to curvature, but not linear acceleration with an aircraft. So, and this was in the year 2008. That is a demonstration of linear acceleration from a craft that we cannot duplicate. And what's more is that, as we could see from the radar data, this object has the ability to suddenly accelerate and then to drop back down to low speeds after having done so. Next slide. So my conclusions, the Stephenville incident is one of the best documented cases involving witnesses with corroborating radar data. The witnesses have indicated high speed and acceleration. The radar data confirmed that, and I calculated values of 2.2 and 9.2 linear g-forces, remember. And these combined capabilities of low and high speed, along with high linear acceleration, makes these events unexplainable with any known terrestrial aircraft. Thanks, and I hope you enjoyed the presentation.
Is there any question? Well, we are close to the roundtable timing, so maybe we have a few minutes. At least, is there any question for the first presentation from Jean-Marc? Because Jean-Marc is connected, so maybe he can answer.
Yes,
So you showed that there were two primary radars getting tracks, and one of the primary radars showed erroneous data. Did you check another day where radar tracks were also recorded to see if it was a fault inside the radar or if it was a possible effect from the UAP that could have scrambled the radar?
Okay, no, I have no mean to see where from what comes the anomaly. I don't know. I don't know. No indication. So I repeat that the selecting process is performed on each radar, and if you have differences between the detection of the two radars, maybe it comes from the process, the selecting process in the radars. I have no means to know the real cause.
Thank you.
Just a remark about that. Do you remind what is the duration of the radar files we had? We know that the period of observation is about 20 minutes or something like that. I don't remember exactly. But I remember that we had the files starting earlier.
Yes. We have about just less than an hour of record. The incident, the observation of the UAP lasts from 14:06 and finishes at 14, I don't remember exactly, 18. Exactly, because we have 12 minutes of observation. The record starts at 13:30 and ends at 14:24 minutes. So it is 54 minutes of record.
So maybe there is a partial answer remaining regarding, I would say, current radar tracks because of the traffic, the regular traffic, maybe ships and so on. If we see before the same features, like for example the radar plots remaining beyond the optical range of the radar, it's probably an artifact of the processing and so on, as we said before, because the thresholding maybe is not the same, is not obeying the same constraints within the operational normal range of the radar and beyond, where they can release maybe the thresholding, allowing more alarms and so on, because it's not the nominal domain of operation of the radar. That's maybe we can see similar things happening before, so we can say, okay, we have this. It's not assumed to have a likely link with the UAP event, even if it's not because Captain Boyer didn't observe the UAP before, they were not there. Yeah. That's another story. But okay, so I think that we are closing to the next roundtable. So we have just to prepare for that, and I leave the seat to Baptiste to manage this international roundtable that he prepared very carefully, and I am sure it will be interesting. We are moving from the technical environment to more, policy and international matters, but that's also one side of the subject. So let's do it. And thank you for the presentation that were made. Thank you for ICU for having prepared the two presentations, the one on the methodology and the other one on Stephenville. Thanks a lot.